This is the project 2. We split everything up into our controller pawn just to make sure everything works. We have our up and down. We have shift. We can go speeds. It goes both shifts. Our A and D rotate ourselves, and then our arrow keys teleport us in world space versus our local over W, A, S, and D. And then our T key, of course, still works, so as we teleport randomly around the world. And then going into the actual code itself, we have our pawn controller model. So we have our controller here, our pawn here. The code, the deviation of the differences. So we have all of our functions. The actual movement itself is inside of the pawn. That is all of our transformations in our delta time. When it actually moves, it calls from the controller, it calls to the pawn. So all of this, all the movement comes in through the pawn. And then we call it by pressing keys through the controller. So these are where all the functions are actually called from. Nothing actually changes here. It just tells the program, go look in pawn for the function move forward, and then it runs it, and then it moves. The random teleport using the T key is somewhere in here. The forwards, backwards, it should be at the bottom. Random TP is a new function I have in here that has all of our random integers that it puts in so that the designer can change things. As you can see, all of our variables are changeable for our designers, so they don't have to bother anybody. We have our location position is equal to new vector random range between our x's, and then our random range between our y's. So we have all of our new vector, our new location is set up right here in the random when you press the T key, or if you want to change it, it's changeable right there. Functionality, W, A, S, and D is constant speed within the local space. We can see in here, we use W, A, S, and D right here. Technically these few. Going into the pawn where all of the code actually is, that's the move forward, backwards, and turns. It uses the transform functions to move. This moves in local space. It is a vector with direction and magnitude in relation to our pawn. So for specifically transform up, it tells the computer that we need a vector from the pawn going in the direction of up, or the y up, y1, and then with a magnitude of 1 as well. So it's going to move it up, and then we multiply that by the move speed. That is just, instead of saying it's going in the direction up 1, it's going to go in the direction up by 1 multiplied by move speed, and then we multiply it by time delta time. Time delta time uses the time class and the function delta time, which calculates the in-between of frames so that everything is run per second instead of per frame. Arrow keys are using world space. Down here we have teleport up, down, left, and right. They use the vector 3 function. Vector 3 is a world version of the transform. So vector up and down is just going to be a vector with the direction up and or down and a magnitude of 1 or -1. Or it's probably just, it's 1, 1. So it's going to tell us where this vector is going to, and then it multiplies that 1 by the teleportation distance, so we can get a distance from the designer to in which direction in how far we want that to teleport from the vector itself, and increase that vector size. The turbo speed is in our controller more than it is our pawn. It's right here. It's a shift, so we have left shift, right shift, one or the other, using these two fancy little lines right here saying it's or. And if we are holding shift and then we press W, it is going to do a sprint speed. And then if we are pressing shift and S, we get the sprint speed again, which is in here. Sprint speed. It's just using the normal move forward, but it's passing in the sprint speed instead of move speed. So a little nice. And then once we press, we have an else, so that it's just going to skip over the normal time, so it doesn't double over on it, just to get that kind of out of the way. Turbo speed. Speed. And then all the designers can update everything. We have our move speed, our rotate, and sprint speed all right here. Nice and updatable, so we can always change these whenever we want, even if we're doing whatever we want, just so the designers can change stuff on the fly without us going into the code using private variables. Makes life so much easier. I have the frame rate independency, going back to that. It's just the time delta time. Vectors, I already did it a little bit, but vectors have magnitude, a direction and magnitude. Direction just showing where in the world are we aiming this line at, and magnitude, how big is this line, how, from what distance am I teleporting my object to, at least per second in this. Local space, I already said it, but just to say it again, reiterate, it's in relation to our pawn, and world space is in relation to the level itself, where local space, the pawn itself, has its own vectors coming from it, while if we use world space, it is from the 0, 0 point in our world. We use the pawn controller model because it is probably the easiest one to use. The controller allows us to keep all of our key functions separate from the pawn, allowing us to destroy the pawn. If we ever need to break the pawn, get rid of the pawn, if our player changes characters, we can always do that by having our controller and just setting whatever the pawn is, we can set it in here, the controller. So if we end up changing characters, we have this, and we can always change the pawn to something else. If we don't end up liking this, or we want this to be a NPC or something, we can always just change what we're controlling itself, change stuff around, make stuff a little bit easier for that. Again, also destroying stuff makes having a controller easier. We can set, if this pawn doesn't exist, our pawn itself equals a different pawn. A lot of word pawn. But that is the game.